Okay, it's 9 o'clock, and out of respect for everybody's time, I'm going to go ahead and start the lab walkthrough for today, which is going to be performed on Packet Tracer. We're rolling, we're being recorded. This presentation will be uploaded shortly later in the day to the recorded presentations session, recording presentations link on the left-hand side of this class of my TCC Blackboard. So looking at mouse action, oh good. So today is Thursday, March the 4th. March 4, it's for marching. So we're going to do lab 15.6.2. We covered the theory and operation Tuesday of static routing, and then we're going to do an actual lab on static routing. No more live lecture sessions after this week. No more live lab sessions after this week. I have already turned on the final exam. It's available on netacad.com. I'm going to pop over there in a second and show you how to get the gotchas about that. So next week until Wednesday at 9 a.m. next week, the 10th, is the final deadline for turning in any work. So in this class, it's the 5 module exams, and the final exam is averaged together, and that's 50% of your grade for your written work. And then the laboratories are averaged together, and that's the other 50% of your grade. And I do drop the lowest lab, so you can safely skip one lab and it won't hurt you any. You guys that are signed up to come back, we're going to be coming back on Tuesday, March the 23rd for the CCNA 4, the capstone class. You'll be completely prepared after that class to go and pass your CCNA certification exam. And that's going to be the exact same schedule as we've been doing here. Tuesdays mornings at 9 o'clock will be a live lecture remote session. And then Thursdays will be live in person in the lab here, or you can do it remotely via Packet Tracer and just watch the tape later. Okay, now let me go over to the Cisco Network Academy for just a second and show you this. So here's our class right here. I'm going to launch the course. So to be able to take in these chapter exams, you just go down here and you click on a chapter exam, and it'll bring up a screen where you can take the assessment and so forth. Let me see, can I kill that? Oops, I shouldn't have killed that. Oh dear. Hang loose. I killed everything. Okay, let me log back into Networking Academy. Launch the course again. Probably gonna ask me for my password now. Yeah, he's gonna ask for my password again now. Okay, and what I want to show you is when we go to the course home here, when you go down to take the final exam, here's the gotcha, is before you can take the final exam, if you haven't taken this course feedback form, which is a student satisfaction survey that's completely anonymous and nobody can see your identity or anything like this. Cisco's very serious about collecting satisfaction surveys from their students because, you know, the Cisco Network Academy has 10,000 academies, and we've had 10 million students pass through our doors, and they want to track their progress and so forth. If you try to take the final exam and you haven't taken this course feedback form, it's going to tell you in this final exam portion here that you can't take the exam because you haven't taken the course feedback form yet. That's a business rule or a business requirement that Cisco has on their website. So I already took the course feedback form on my fake student account. So when I click on final exam, it's going to be just like taking one of the chapter exams. You'll click take assessment, you'll go and you'll take the test. If you see any stuff about Packet Tracer, I'm going to do a bit of extra credit at the end of the course to allow for Packet Tracer, which doesn't always work great on all platforms. If you can get Packet Tracer working on a test that requires it, and you get the questions right, that's going to be like extra credit for you, extra credit for you. Okay, so let's see now. We're going to go and do this lab now. Let me kill this. And here's a copy of Packet Tracer. I'm using Packet Tracer 8, the newer version, because I'm going to go into the cool Packet Tracer physical mode and set up the first part of this lab. And then we'll actually go in and complete it. Hold on, I got to bring this up here where I can see it. Okay, so the first thing I'm going to do is build the network up according to this topology that's on the front page. So I'm going to use so that the interface port numbering schemes on this lab match Packet Tracer. I'm going to use the 4000 series, the newer series of routers, so that we have G000 and G001, and it matches what's on the lab. If we were performing this in the laboratory here, we would be using our 1941 routers, and they're G00 and G01. You can simulate a packet tracer and do that, but if you pull one of the 4000 series routers up, the numbers are going to match just exactly. So that's what I'm going to do. So first of all, I'm going to go into the physical mode to provision these. So I'll click on physical. Packet tracer comes up by default in the logical mode. I'm going to click on physical, and then I'm going to open up home city, and then open up the corporate office, and then open up the main wiring closet, and I'm going to put in 2 racks. So I'm going to click on this button here. That's add a rack, add 2 of them. Now let's provision our devices. Let's provision the routers first. So I click on the network devices, and I'll provision a 4321 router, and I'll put it in the middle here. I'll provision another 4321 router and put it here. And I'm going to drag this power strip. It's not a top of rack switch, it's just a power strip. Anytime you provision a device, you ought to make it get a power strip. And I'll move the router up a little bit in each one of them. See if I can line them up here. And then let's provision a couple of switches. So I'll provision the 2960 switch, put it there, provision the second 2960 switch and put it there. See if we can get them to sort of match each other. Okay, they're sort of lined up. Let me increase the magnification here and bring these devices to where they can be seen. I can do a little bit more here, and we can see a more up close view of the devices and the switches. Can't see all the switch ports on the right of the second switch, but we're only using switch ports 4 and 5, so we'll be able to see that. Okay, first thing I'm going to do is click on this router and click config, and he's going to be router R1. So I'm going to type R1. I'm doing it so this matches the exact layout on the front of the lab page of this lab 15.6.2. Now I'll click on the second router, click on the config tab, and make him R2. Now let's get a hold of switches. The first switch will be switch 1. And the second switch will be switch 2. Okay, now that oops, I mistyped that. Oh dear, that's switch 2, not R2. R2. Okay. So R1, R2, S1, S2. And here's the physical layout in the 2 racks. And if we pop back to the logical, it typically shows them kind of screwed up looking. So we're going to drag them around and make it look nicer here. R1, R2, S1, S2. Kind of looks like the lab report, the logical layout. Let's go back to the physical layout and let's make the connections that are required here. So in the front page of the lab, we can see that G000 of R1 is connected to G000 of R2. So I'll click on the wires connection, and just to make it a little easier to see, when I connect the 2 routers to each other, I'm going to use a crossover cable. That way it'll show up as some of the wires will be orange and some of the wires will be green, and a little bit easier to see as they overlap. They sort of dangle in this new version of Packet Tracer. So I'm going to go to port 000, which is this one, and I'll connect that to port 000 of this one. And now we have our dangling wire. Okay, now I'm going to go and do the same thing with the 2 switches. I'll use orange as well on that from switch to switch, and then we'll use the green wire as the different devices, switch to router, switch. So the switches are connected together with their port number 4s. So I'm going to find port number 4, click on it, find port number 4 on the second switch and click on it. Now we have a dangling wire connecting the switches together. Now let's connect R1 to S1 and R2 to S2. And I will use a green wire for that just to make it a little easier to see on the print. So we're supposed to go to port G001. If you float your mouse over here, it'll sort of light up with the port number. So there's port 001. I'll click on it, and that goes to port 5 on the switch. There's port 5. Now we'll go to the second router, and we'll go again and provision another green cable, and we'll go to G001 and put that on port number 5. There we go. Now in this new version, you can also hang your mouse pointer over a wire, and that whole wire will turn bold, and you can see that wire. If I've got a bunch of wires that are all the same color, just like in real life, it's hard to tell which wire is which. But by using a couple different colors here, it makes it a little bit easier to see what the interconnections are. Okay, so when I go back now to my logical layout, yeah, the wires are connected. And I've turned on the feature in Packet Tracer under Options, View Interface Ports, where we can see the interface port numbers that are connected together. That's off by default. Okay, so everything appears to be connected together pretty well. So let's start cooking through and doing the lab here. So first of all, we're going to go to each router and assign them a host name. So I'm going to go back to the logical topology to do this, and I'll click on router R1 and go to the CLI. And let me see if I can make this print a little bit bigger. If I go into Options, Preferences, Fonts, and maybe make that font size just a little bit larger. Maybe that'll make it a little easier to read. So go to the first router, and that's a little bit there. This kind of micro print. Okay, so this is router R1. We can see up here that we've that we named it on the blueprint. We named it R1 on the logical diagram. But let's go ahead and make it actually R1. And we're instructed at the top of page 3 to go to the exec mode. And then we have to go to the global configuration mode and then give the hostname command and make it R1, and it changed to the prompt, so that's good. Okay, the next thing we're instructed to do is do this exact same thing on R2. So I'll go to R2, we're on R2, go to the CLI. Let's see, if I click top on this, maybe I won't have to resize it every time. So enable configure terminal, hostname R2, that one. Now what we're supposed to do, go back to R1 and do no IP domain lookup. So let me see if I'm, okay, I have to minimize it. Let's see, is R2 present here? Okay, R1, go back to R1. I'm gonna do a top on it so I don't have to keep resizing it. This should keep it where I shouldn't have to resize it over and over again. And we're instructed to, we're still in the global configuration mode, no IP domain lookup. And that's the command that if you accidentally enter a command, incorrectly spelled command, it won't hang you up for a minute while it tries to, telnet to it or ping it. And I'll go ahead and do enable secret class on that one. Now let me see if I can go back and pick R1. Oh, we're on R1, let's pick R2. Okay, good. Now let's do the same thing to R2. We're still in the global configuration mode. So no IP domain and enable secret class. Now let's go back to R1. And we're instructed to do the line console 0 password Cisco. So line console 0 password Cisco login. And I'll go ahead while I'm still here. I'm going to do the next two commands so I don't have to jump back so much here. So I did line console 0 password Cisco. Now I'll do line PTY 0 through 4 password Cisco login. And then the service password encryption command, and then let me repeat that on R2. So we'll bring up R2, we'll repeat those three commands. So line console 0 password Cisco login, line PTY 0 through 4 password Cisco login. And Packet Tracer is a little weird. If you try to do, on a real machine, you can actually go from different configs. On Packet Tracer, it doesn't do the tab completion unless I go back and do the original configure T, and then do service. Makes me look like an awesome typist. Okay, we've done this on both routers now. Now let's do the banner message of the day, and I'll skip back to R1. And we're going to do, we're at the global configuration mode, banner message of the day. And what does it tell us to say? You can say anything you want to. He's using notice he's using the $sign as the delimiter character. I'm going to use the pound sign because that's what I'm used to. You can use any character you want to as a delimiter character. What it looks for is whatever you type, whatever character appears after the MOTD, whatever that character is. And then you put your message, and then you put that character again. That tells it what's in between the pound signs will appear. And the lab, what's between the $ signs will appear. So you can't use a delimiter character that would appear in your intended message, or they only see a fraction of the message. So authorized users only, something like that. And then put another delimiter character. And then we're instructed to do a copy, run, start to the configuration, and I'll repeat that on R2. So banner, message of the day, authorized users only, whatever your company management or logger tells you to say is what you put here. And then let's do a copy, run, start. Copy, run, start. Copy commands have to be done from the privilege exec mode. You can't do it from the from configuration mode unless you use that secret Gonzo insider tip, put the word do in front of it. Dudley do right. You can type do right and you can do the right configuration instead of going back. Okay, now let's go do some basic configurations for the switches. Okay, so I'm going to minimize this and minimize this. And let's bring up, he tells us to work on switch 1 first. So I'll click on switch 1, make it stay on top so it doesn't have to be resized every time. Click the CLI. Okay, the banner tells us that we're on switch 1, so let's go to the privilege exec mode and go to the global configuration mode and give it a host name of S1. And I'll go ahead and do no IP domain lookup. No IP domain lookup. Okay, let's try it this way. No IP domain. It is domain lookup. And enable secret class. I'm gonna go ahead and finish all the commands on this page, and then I'll jump to switch 2, and I'll do the commands on him as well. So line console 0, password Cisco, login, line VTY 0 through 15, password Cisco, login, and then he says to encrypt the plain text passwords. That's the service password encryption. Path completion to work better here, service password encryption. Okay, let's go and do the same thing on phone. Minimize this, pop it to the second switch, bring it to the CLI, expand it. Okay, we're in switch S2, no configuration has been done on this yet. So we're going to go enable, configure terminal, host name, switch number 2. No IP domain lookup. No IP domain lookup. Enable secret class. Line console 0, password Cisco login. Line VTY 0 through 15. Cisco login. And then service password encryption. Look on top here so he remembers the resizing of the screen. Okay, now we've got to the top of page 5 of the lab, and we're going to do the banner message of the day on both of these now. So I'll go to switch S1. We're already in the global configuration mode, banner message of the day. Authorized users only. And then let's shut down all interfaces that will not be used. So Let me find that command here in the print. So let's see if this works here, if I can do this. Okay, config-if range, and we specified the switches that we're going to shut down these ports. They're not being used. And we have a whole string of commands on the screen for this. And let's see, is switch 2 is exactly the same for this. Okay, good. So we're supposed to type, we're supposed to go back to the privilege exec mode and do a copy run start. Now let's see if I can do this smoothly on the second switch as well. S2. We did service password encryption, so let's do that banner, message of the day. Surprise. User only. And let's see if we can do that to switch port command and paste everything down. Okay, so shut down all those ports that should not be used. They've all been shut administratively down. And I'll do a copy run start. Let's say the configuration of the NVRAM. Now he's telling us to use the, let me go back to switch 1. Did I do the correct command on switch 1 here? Yes, they're administratively down. Okay, so if we check on switch 1, if we do show the interface brief, you can say that we shut down a bunch of ports. The ports we're using on the switch is port 4 goes to the other switch, and port 5 goes up to the router. You notice the port up to the router is, port 5 is down and down. We haven't done any configuration on the Ethernet ports of the router yet, so they're shut down administratively by default. So if I issue the command, show me your Cisco Discovery Protocol neighbors, please. The only thing switch 1 sees is switch 2. The only thing switch 2 sees is switch 1. R1 and R2, if we went to R1 and R2 and issued these same commands, he says it's an empty list. So let's verify that. Let's go to R1 and R2. So I'll go to R1 and I'll do it. Show me the CDP neighbors, please. There's no neighbors. It's all the ports. Look at the ports. Show IP interface brief. Cisco Discovery Protocol requires only layer 2 connected, layer 1, layer 2 connectivity. It's a data link layer protocol. The ports have to be not shut down, but they're all still administratively shut down by default. So until we fix that, when we configure the routers up, they're not going to be able to see their neighbors. So my little trick is being able to check what's in the labs is go ahead and do a no shutdown on R1 and R2. You don't need to apply an IP address. Just shut down the ports that are interconnected. And then when you do show CDP neighbors, they'll show, you can verify that the right switch is connected to the right other switch and the right other router and so forth. And before you get deep into lab and configuration and realize, oh, maybe I've got my console cable swapped and I'm configuring R1. I thought it was R2 and I got to start all over again. Okay, so we're at the middle of page 5 and we're going to go into part 2 now of the lab. And we're supposed to start with R1. So let me find R1 in my list. So we're at R1. We've done some configuration. We did some saving. But we haven't applied any Ethernet addresses yet. Haven't done any no shutdown and applied any IP addresses to any of these ports yet. Okay, so the first thing I'm going to do is go to the global configuration mode. And this lab has some Ipv6 addresses in it. So by default, Ipv6 routing is not turned on, just IP4 routing on Cisco routers. We want to turn on the Ipv6 routing function. So we're going to type Ipv6 unicast routing to turn on that function. And then we're going to configure some addresses here. So I'm going to go interface gigabit 0/0/0. And the IP address, version 4 address is 172.16.1.1, 255.255.255.0. And then let's give an IP6 address. And there's a couple here. There's a link local address, which is locally significant only. And then there's a globally unique address. The 2001 range is reserved for documentation and training. So our Ipv6 address is FE80::1 link local is the address between the routers. Routers will share routing information using their link local address. They don't want to consume a global unique address. And then we're going to give the second IPv6 address. Let me make sure I type it in correctly here. IPv6 address 2001 colon DB8, and that's case insensitive. You can type those when you get those hexadecimal A, B, C, D, E's, and F's. You can type that uppercase or lowercase. It'll work just fine either way. 2::1/64. Make sure I type that correctly before I press enter. IPv6 address 2001 DB8 ACAD 2::1/64, and let's do a no shutdown on this port. Now let's go to interface gigabit 0/0/1, and he's going to get some addresses. IP address 192.168.1.1. Ever heard that one before? 255.255.255.0. And we'll do an IPv6 address of, here's the link local address, MB80::1 link local. Now wait a minute, we did a link local address on 0 and 1 and the same number. Duplicate IP addresses is a problem? No, they're only within that broadcast domain, within that particular wire. So G000, if I made R2's G001, that would be a problem. But this is just going down to the switch, so they're not conflicting with each other. Nothing confusing about that concept, right? IPv6 address, and the global unique address is 2001 DB8 CAD 1::1/64. And let us do a no shutdown on that second gig port. Okay, now we're going to create a couple of loopback. The loopback addresses are addresses that are just handy in labs for that we can ping. When we do OSPF in the next chapter, in the next class, we'll see, oh, we can use it as a OSPF identity. So let's go ahead and do interface. I'm going to go ahead and go back to the pure global configuration mode and go back and nice and clean. And we'll say interface loopback 1. Loopback ports are born alive, up and up. You don't have to do no shutdown on them. You can shut them down and then do no shutdown on them again if you want to disable and re-enable them. It's like the 127.0.0.1 in your desktop PC. It's always there, and you can always ping it, even if you're not really plugged into a network. Okay, so the IP address is supposed to be, this loopback number 1, it's supposed to be 10.1.0.1 with a /24. And then he's going to get an IP version 6 address, the 80::1 link local, and then another IPv6 address of 2001:DB8:, make sure my typing is okay here, ACAD, network subnet 10:1/64. Now he has here to type the no shutdown command for a link for a loopback port, but it's already not shut down. You didn't have to type that. Okay, now let's say interface loopback bigger terminal interface loopback. He's born up and up. IP address 209.165.200.225, which looks like a valid global unique IP address you'd find on the world internet, but that's another special reserved address for training and documentation. 255.255.255.224, smaller network there, and then IPv6 address FE80::1. Again, it's its own subnetwork, so we can duplicate that address. IPv6 address 1:DB8:ACAD 209:1/64. And I'm not going to type a no shutdown command. I don't have to. Show IP interface brief. See, it's up and up. I don't have to do it. Show IPv6 interface brief. They're all up and up. I didn't have to do that on it. Okay, now let's go over to R2 and let's do his addresses. So I'll click on R2, bring him up here. And since it took me more than 3 or 4 minutes to do this, he kind of like a real device, he logged me off. So the password is Cisco, exec mode, it's class, configuration mode, and I'm going to specify interface gigabit 0/0/0/0. Address is given as 172.16.1.2. 255.0. IPv6 address FE80::2. Link local. Why did I not make it 1? Oh, well, this G00 goes back to the G00 of R1. He's FE80::1. Since they're both connected to the same broadcast domain, the same wire, he has to be a unique value. Otherwise, it'd be a duplicate IPv6 address. And machines get really upset when they have duplicate IPv6 addresses. Microsoft computers put up a message on the screen that says, it means this: I'm taking my toys and I'm going home. When Microsoft computers detect a duplicate IP address to what they're configured to, they shut the networking down for safety, so they don't want to mess things up. Okay, now we're going to put in the globally unique IPv6 address. And that is given as 2001:DB8:CAD:2:2/64. And we do need to do a real shutdown on it because it's a real device. Now let's go to interface. Interface gigabit 0/0/1. The address is 192.168.1.2, 255.255.255.0. IPv6 address. IPv6 address. Oh, well, let me make sure I'm doing the right port here. Z000. Hold on. I think I'm just trying to configure it wrong. Let's do a show IP interface brief. And G000 is supposed to be 172.16.1.2. Okay, that's correct. G001.1.2, that's correct. Okay, show IP interface, show IP version 6 interface brief. G000 is supposed to be 2001 DB8:CAD:2:2. And G001, oh, I haven't assigned it yet. Okay, I just want to make sure I didn't get confused here. Bigger terminal interface gigabit 0/0/1. 6 address. 80::1 link local, and the IPv6 address, the global unique address is 2001:ACAD:1:2 with a /64, which is your normal mask or prefix size for IPv6. No shutdown. Okay, now let's add the loopback ports for router R2. We're on R2. We're still on R2. Good deal. So configure terminal, interface, loopback 1, the address 10.2.0.1/24. IPv6 address on this loopback port is 80::2 link local. Globally unique IP version 6 address is given as 2001:DB8:11:2/64. And I don't have to use shutdown now. The shutdown command on the loopback port. It's automatically up and up. Okay, now configure terminal interface loop back to IP address 209.165.200.190. 255.255.255.224. Ipv6 address Ip80::2 link local. Multi-link IP address 2001:DB8:academy:210:1/64. Okay, that looks good. Okay, let's verify addressing. Okay, we're gonna pop back to R1. Show me R1. There we go. Like that. Show IP interface brief. Show IP interface brief. And the number should be 172.16.1.1, 191.191, 10.101, and 209.165.200.225. Looks like I put the correct numbers in. In the print for the lab, they show some serial ports. I didn't provision any serial ports on this router, so they won't appear on this unless you put them in there on purpose. And then we'll pop over to Mr. R2 and do a show IP interface brief for him. Print for the lab, and he shows that it's 172.16.1.2 and 192.168.1.2, 10.201 and 209.165, 201.93. Again, I didn't fat finger anything there. Now let's do the same thing for the, I'm going to skip back. Let's do a show Ipv6 interface brief. And we'll check on the second print. So it's FE80::2, 2001 DB8 ACAD2::2. 001 is FE80::. I made a mistake on the G001. I got to fix that. FE80 DB8 ACAD1::2. Loop back is 2 and 2, and 2000 ACAD 11 and 210. Okay, I got to fix a problem with that gigabit 001. I thought he told me to type that, but I'll fix that. So configure terminal interface gigabit 0/0/1. No Ipv6 address FE80::1 link local. Wait a minute, which one is it supposed to be? It's supposed to be 2. And then Ipv6 address link FE80::. He says he's supposed to be 2 link local. Fingers get so used to typing the FE::1. Okay, now let's save the configuration of both machines. Before I save it, I'm going to pop over to router R1 and check R1, make sure they make a similar mistake on them. Show Ipv6 brief. 6 on number 1 is supposed to be FE80::1, 2:1, FE80::1, ACAD11, 2:1, 10:1, FE80::1, 209.11. Okay, so let's save our configuration. Copy, run, start. Save the configuration. The question there, I had to put a couple questions on this lab so you at least had something to answer on that. So near the bottom of page 7, save the running configuration to the startup configuration file on both routers. The legacy command is copy. Actually, the current command is copy, run, start. Saves it. Now I'm going to show you I think I've mentioned this in this class before. We'll go to R2 and we're going to save R2's configuration. So I could type copy, run, start, but there's a command called write. It's the old deprecated version of copy. So if I do write mem, that's like copy, run, start. Writes to NVRAM. The default for write is write mem. The shortest you can type write is WR. And the reason I like just typing WR is it saves it and you don't have to press enter twice. If I type copy, run, start, press enter twice. Write does exactly the same thing. Okay, so we've saved the configuration on router 1 and we saved the configuration on router 2. And now we're going to configure some static routing. Oh, scary new static routing we're going to do now. Okay, I'm going to pop over to router R1. And he's given us a command to make sure that the static, put in this route for R1. It's supposed to be in the global configuration mode. So R1 and then I'm going to enter this command here. Hang loose while I find my print. Okay, we're supposed to enter the command of IP route 20.10. Let me see let's type it correctly. 10.2.0.0.255.255.2.0. Okay, so this is the route that's not on this machine. He needs to be told how to get there. That's on another network that's not in this broadcast domain. This is the subnet mask of that network, and this is the next hop ID to get there. So I should be able to just press enter, and it'll take that command. And then we're going to put in the static default route for R2's G00 address. So this command is given as IP route. Now the quad 0 is a special default route. Most companies are not going to use static routing for everything like we're doing in this lab, because it's too cumbersome. If the network even gets complicated, or if anything changes, you have to change static routes on a bunch of devices. So what normally we're going to do is, when we come back from spring break, we're going to use the wonderful OSPF as a dynamic routing protocol. He'll do all the routing for us automatically. Even if things change or lines drop dead, he'll find an alternate route. But we still need a default static route to go back to the home office if you're a branch office, or to your internet service provider, so you can get the connection back to all your home offices, all your branch offices, and everybody that's on the internet. So the 0000 is the wild card that matches all IP addresses. So this is essentially telling the routing table, if there's no specific route that's in my routing table because I did a dynamic routing protocol, you would normally have to drop this packet if it had a destination address that was off the company network, say an internet address of a website like Microsoft.com. But this line in the routing table will tell the router that no, if it doesn't match, 0 more bits don't match, don't drop it. Instead, send it to that next hop IP address, 172.16.1.2, which would be our home office address or our internet service provider address that they give us. So I'm going to go ahead and press enter and put that route in. And now we're going to configure a floating static route, which is the route that would take over if the primary route failed for any reason. Like if, for example, in the real world, we're probably using a dynamic routing protocol like OSPF. And if that route failed, we could put in a floating static route to take over and do this. So this command is given as it's the same default static route, but it has a administrative distance of 80. By default, it's 1. So he's going to use the first line here. He's going to use this one primarily. If that line fails, he'll use the backup route, because in this topology, we've got redundant connections. We got 2 ways, so we can go 2 ways and get to any way in this network. Okay, now we're supposed to go to router R2 and do some stuff on it. So I'll go to the global config mode, and on R2, we're supposed to put in a default route. So if I type in this command, IP route quad 0, there's the next hop IP address. That'll create the default static route for back to R1. Now let's make sure these routes are operational. Let's go back. He's going to have us go back to the router 1. And we need to do a show command. So let's show the routing table that's present in this router at this point. Anything like the print. There, we see. Okay, so we got the static route 172.16.1.2. That looks good. We got the 10.1.0.0. I got the 10.1.0.1. We got the static route 10.2. This looks pretty kosher to me. So on R1, we are instructed at the top of page 9 to issue the command of trace route, which can be abbreviated just to trace 10.2.0.1. And he traced the route to 10.2.0.1. Now let's go to trace route. I'll abbreviate it this time. Trace 209.165.200.193. And okay, we're getting a star here, so something's gone wrong here. Oh, let's issue the shutdown command on R1G00. Let's go ahead and do this. Gigabit 0/0/0, do a shutdown. He's instructing us to type the command show IP route static, which gives us a distillation of the routing table where we just see the lines that they're interested in. And it should be 0/0/0. 80 is now the default static route. We shut down the interface that was associated with the original default route, which had a metric of 1, and now the other one is working properly. Now we need to do a no shutdown. Bring that port back up again. So config T, interface G0/0/0, do a no shutdown, and we'll do it really well now. Now we're supposed to configure some IPv6 default routes. This is a dual stack router. We're doing IPv4 and IPv6 at the same time. And just to check my topology here in the logical diagram, I'm going to bring this down and look for any, I don't see any red lights. So we got physical layer connection, okay. We should be able to see all our neighbors properly now. So if we go to router R1, for example, let's do a show CDP neighbor. You can see S1, I'm connected to down to the bottom. I can see R2, which I'm connected to on the right. That looks good. That's fine. Okay, now we need to be on router R2 for this next step. I'm near the top of page 10 of the print, and we're going to do part 4. It's supposed to be on R2. Let's bring up R2. Let's go back to the plain old privilege exec mode, and then we're going to go into the global configuration mode. I'm rolling. Configure terminal. So we're supposed to, let me bring this IPv6 route in here. And now we're going to configure a default static route. Now, when we did the IP version 4 default static route, it was 0.0.0.0 space 0.0.0.0. But in IP version 6 land, the way it's 128 bits. You want to type 128 zeros, and then again for the subnet mask prefix length. So the double colon means 128 zeros. Anytime you have zeros, you can replace them with a double colon. So there's nothing but a double colon. That means the address portion is all zeros, and the /0 means the prefix length is also all zeros. And then here's our next IP address to connect at that particular network. And now we're going to do the same thing. We're going to press enter just to take effect. Now we're going to configure a floating static route. Metric administrative distance of administrative distance of 80, so that when we do something to make that first route die again, we're going to turn off that gigabit port. When we look on the routing table, that alternate one will have been punched in there. Okay, now we're instructed to go back to router R1, and we're supposed to put in the static default route for R1. So I'll go to the configuration mode, R1. We're going to put in this value for IPv6 route. And again, notice it's a default static route because the address is : all zeros. That's going to be some address that's outside of your company network or back at ISP or some address back at the home office. So you have connectivity back to all those places. We'll punch that one in there. Now, we're instructed to type the show IP route command from router R2. So I'll go back to R2, and we'll go back to the regular old privilege exec mode. I want to show the IPv6 routing table. And now the peculiarity with, let's see the whole thing here. The peculiarity with IP version 6 and IP version 4, when you do the show IP route, the default static route is always marked with the asterisk. That's the way of last resort. Okay. When you do show IPv6 route, it just shows it because IPv6 is totally classless, classful networking ended in 1995. So it just shows it as an S, but it's still the default route because you can see the address listed as the ::/0. That's the default route. And the metric, the administrative distance is 1. Where's our /80? Well, that's not in effect yet because we didn't shut it down yet. We want to make it appear by making it shut down. So I'm going to skip to step number D on page 11. And I'm supposed to go to R2 and shut down that port. So if we do a show IP interface brief just to see which ports are shut down, they're all up and up and up and up. But I'm supposed to shut down configure terminal interface gigabit 0/0/0, and let's do a shutdown. We're going to artificially simulate some type of network problem. So now when I look at show IP interface brief, gigabit 0/0/0 has been shut down. Now, what the heck has happened now with our show IPv6 route? Well, look at there. Now the metric of 80, the floating static route, the interface that he was using for the one metric, the default metric, is shut down now. So he tore it out of the routing table. He searched around for the floating static route. He found it quick as a wink before we could even type it in. He put that in there. So that works okay. Okay, good deal. All right then, so I demonstrated this. We've done the cool physical topology. We've done the cool showing logical. We've done the cool physical dangling cables thing with the new version of Packet Tracer. And I think I've demonstrated everything in the lab. Okay, so you guys, finish these 5 module exams, and the final exam for your 50%, which is your written work, your 6 exams averaged together. Finish all your labs. You can safely skip one lab. That's the other 50% of your grade because I will drop the last lab. So submit that work to me and get all that taken care of by today's Thursday. All work is due by almost a week. Got almost a week to do all this stuff now. By next Wednesday morning at 9 a.m. is the final deadline for all work because I've got to turn the stuff into the dean. Our dean was in the Marines for 30 years and he's not going to accept any excuses for delays. There's only 3 possible answers to answer when you're in the Marines. That's yes, sir, no, sir, and no excuse, sir. And I don't want to have to go up there and say no excuse because I couldn't turn in the grades on time. Okay, hang loose. I'm going to stop the recording.